Okay guys, so today we're gonna talk about antennas, and specifically we're gonna talk about 2.4 gigahertz antennas. Okay, we're gonna test just about this. These are all the antennas you get mostly from buying your transmitter module or a remote or the handset. So like Namimno, they will give you this, and Monopole, they have also the Monopole. And then yeah, this is from Special Guy from Paul. Thanks, Paul. This is from Fantak 900. This one Jumper. This one is ORT 2.4. I bought this myself. And this one is from Orange. So Orange is a local shop. I think it's a home industry. Okay, so before I start yada yada yada, this we're gonna talk about something like this. Okay, we're gonna talk about their grade according to measurement tools. Okay, not just I'm testing this, I'm testing that, oh it's good, oh it's bad. Okay, I'm using a scale measurement tools which would produce consistent value. So first, when I'm selecting antenna, I'm looking for which is my first intention. Okay, whether it would be long range, or B it would be freestyle, or C it would be test rig, or just plugging an antenna so I don't blow things up. Okay, don't blow up please. Okay, so when I'm selecting about long range, what I'm gonna look out for is that I'm gonna look out for one, is this brand or is this designer or is the factory is a good one. And then two, I'm gonna decide, does this antenna actually has a good SWR, a good return loss, or VSWR, which is the same as return loss. Okay, I cannot type today. 3, I'm gonna check the DPI and the pattern. See, I cannot type today. And the pattern. Okay, and then for freestyle, so for long range I want this number to be at least below 1.5. Okay, and for freestyle, what I'm gonna check for freestyle is SWR, return loss, or VSWR at least below 2. Okay, and then 3, although it's not really important this thing, but I do sometimes check at least the pattern. Okay, and if I do have the diversity VRX on me, I'll use one omni and also one directional. But if I have only normal receiver that doesn't do diversity, probably I would only use one omni, as it is enough for the range of my freestyle or my race. Okay, race go here as well. And then for test rig, still on test rig, I wouldn't want something below, I don't want anything higher than 2 for the SWR, but sometimes I do end up with something that's about 2.5 or even 3. But when this happens, so when I plug in an antenna this bad, this disgusting antenna, I would only crank up my power at least just 10 milliwatt or bit mode. I would do that also when the SWR is 3. But if it's higher than 3, I would just throw it away or feed it to my dog. Okay, it's disgusting. And so let's talk about the antenna. So when I'm picking for the brand or the designer or the factory, what I'm looking out from them is, okay, where's my browser? Okay, so let's say VAS. Okay, so even though this one VAS is considered as one of the expensive antenna, but I like this one. I mean, I like VAS because the way VAS got the nerve to build to VAS got the nerve to put his measured value with their products. Okay, so see, he got the nerve to put this kind of value. That means he's professional. Okay, then look at here, he got the nerve to put this value. Yeah, not most not every antenna company or so-called company would put this value. Sometimes they put a value like VSWR is at least under 2, but that's disgusting. It could be anywhere. 1.9 is under 2, but it's still shit antenna. Okay, so if you look at Foxeer is good brand also, and it's not that expensive. But the thing about Foxeer is, check this out. So they posted everything, including the photo during their measurement. Okay, see how they tune it to 1.1 and up to 1.6, 1.8. They even got the pattern from, I'm not sure what's this length, what this means, but this could be from simulator or real data measurement. But at least they got the nerve to provide us the data. And also there is I think Martin Baird. So Martin Baird, this guy, his work is kind of open source, but there is some company that's creating like this. There's some company that's creating based on his design. So if that company is creating something based on his design, usually it must be good, because that company will produce a few samples and they will try to maintain consistency. So if their first few samples is good, the next one will, because it's probably gonna be a machine work, so it's gonna be duplicate of the good one. So it's just gonna have to rely the company QC. But the design itself, this guy have his design measured from antenna test lab. Okay, so this guy is really doing it. You can see all the specs, you can see all this pattern, you can see Okay, yada yada yada. So let's go back to data. Okay, so this is my offset mark, meaning this is where this is when I don't have my antenna on, and then I measure it, so all the power transmitted will be reflected back to me. And I got through an attenuate. Oh my god, I cannot speak. Attenuator. So attenuator. Okay, so this is the power I get reflected back to me in 100% without antenna. I got about minus 26 up to, so about minus 22 up to minus 26, but just for easier measurement, let's just call it minus 26. Okay, and the band we need would be from 2400 to 2500. Okay, so let's see what Moxon has. Okay, so happy model Moxon. Why this is why I put a question mark there, because happy model Moxon is a bit different than all the other Moxon, but we can still categorize it as Moxon. So happy model Moxon, I got at its center frequency, I got 1.2 VSWR, which is actually it's pretty good. Yeah, it's almost perfect. So perfect is 1, below 1.5 is good, but higher than 1.5 would be shit. Okay, well, it's not shit, you can use up to 2, but I wouldn't use anything above 2. I would just, for me, because I like my stuff, I like some reliability with my components, so I like to use everything that's below 1.5. Okay, sometimes they are a bit more expensive because they are tuned. Okay, and then there is this jumper Moxon. Okay, so from what I heard is that they tune it, they after they produce it from the machine, they hand tune it also, but I'm not really sure if that works to all the antenna, but at least this is very good result from them. Okay, so at its lowest return loss will be minus 47, but we're gonna use 2400 up to 2500, which is about minus 40. Okay, so here minus 40 up to minus 26, we get about minus 15. We get about minus 15, 1.4. Okay, that's good. So we got flat out 1.4, with probably we got 1.3 or 1.2 here at 2400. The SWR was flat good, always good in all the frequency we're gonna use here. And then this one is Namimno. Okay, so it's very strong here on its center frequency. So it's about minus 62, which is almost perfect. Yeah, it's about minus 40. It's about, see, it's about 1.0. This is very good. Sadly, unfortunately, their center frequency is a bit out of our range, so we're using 2500 up to 2400, meaning we're using somewhere about here maximum, which is minus 50. That's still good. If you look at over here, minus 50, which means minus 30, we got about still 1.0. Okay, but about here we get about 1.4, 1.4, 1.5. It does getting stronger at the end of the frequency band. And we look at Namimno Moxon. Okay, this is really good, same as jumper Moxon. It's really flat out on the minus 40 above. It's minus 44, 45 maybe, so it's probably 1.2. This is very good. Then this is the orange ground plane. This guy is really fine tuning it. It's minus 52, minus 53. and also in the frequency that we used. Okay, so we're getting about 1.0 or 1.0 SWR, and up to 2500 we're still getting about 1.4 1.3. This is very good. Okay, and then on the ORT Dipole. Okay, so this brand is quite famous, but yeah, turns out it only goes up to minus 34, which is only about minus 8 from minus 26 dB. And if we look at minus 8, okay, this is 8.5, it's 2.2. Okay, so yeah, a bit disappointing. So probably I'm not gonna use this antenna. Okay, so all my test measurement, I got no sponsor from anyone, and all this measurement I'm just reading it from the data I have from my measurement tools. Okay, I'm not cheating, I'm not doing anything unnecessary because no one is paying me to do this. I'm just doing this so you guys know at least which antenna is good and which is not, and how to pick an antenna, how to buy an antenna, especially if you are thinking to buy some expensive antenna, some branded antenna. At least you know how to pick which brand, because yeah, if I'm buying something expensive, I wouldn't pick shitty brand, that doesn't have the data provided anywhere. It's disgusting if you're playing in the world of technical stuffs like electronics and mechanics. Yeah, you always have to provide data, unless you're cooking. If you're doing cooking, if you're doing bakery, you don't have to provide data. You don't have to put out your recipes to your customer. You just go bankrupt if you do that. But with electrical and mechanical and with technical stuff, data is necessity. Okay, and that's all for my video. Please like and subscribe and comment down below what do you think about it. How can I improve for my next video? I'm sorry if I'm a bit boring. I tried to cut down everything. I don't want to talk too long, but I ended up talking too long, and maybe it's boring for some of you. Okay, thanks for watching anyway. If you are still watching up to this point, thank you. Okay, so I'm sorry, I'm an amateur video creator. So turns out when I was recording and switching between browser to show you guys the return loss to VSWR table, seems like the screen recording stays at the previous window, so it never switches together. But so here I created a table about almost all of them, which is this is on their center frequency, or at least I try to find their lowest return loss frequency that's still in between 2400 to 2500. So like now you know it was above 2500, I picked the one at 2500, and then the value at 2500 it was minus 55. I would just subtract the offset mark, which was minus 26 with the return loss number. Okay, so like minus 26 with minus 34, I'll get 8 is the return loss. Okay, then I will look it up in the VSWR table, and it will show about what, 2.2 was it. Okay, so I finished up looking up the table, and put it down here. So here are the return loss value, the value after I look it up in the VSWR to return loss to VSWR table. So okay, so the best here is obviously was, well, I cannot say it's the best because it's also minus 55, but at the end of the bandwidth. So, but at least everyone here is below 1.5, which means these are all good antennas. And then we haven't talked about the TPI, the pattern, which also will improve the antenna range. Okay.